What's up, guys? This video is going to help you quickly get started using the basics of maci. If you would like a full comprehensive deep dive of maci, please watch the full training series. Link is in the description. We're going to quickly cover the maci language and some of its functions and how to use it in code, and go over the external libraries and how to use some of those functions with maci like JSON or YAML or TOML. Let's get started. So to install maci, just type pip install maci. There are other install flavors of maci you can find in the documentation. We'll go ahead and import maci simply by just typing import maci. Now let's first quickly take a look at the maci language inside of our pretend game.save file. You can actually use whatever file name you'd like. What really matters is how you structure your data, and the way maci does it is styled after Python. So if we just quickly run down each item here, you have your basic comments in the file, then you have your strings, and then your integer, your float, your boolean, none type, list, dictionary, tuple, set, byte data, and maci natively supports datetime objects expressed like this. And there's a few other ways you can express it. You can look in the documentation. So let's go ahead and load our data into the program. All I have to do to load our data is just type maci.load and then our file name. And then we store it into our data variable here. And if we run this, we see our maci data object and all of our names and values. Now let's bring our game save file right over here so we can easily see the names. And so if we want to access, let's say username, we can just type .username. And then when we run it, we see our value. And we can also type unique items, run it, and then we get our set of unique items. And all these values that are getting loaded are the equivalent Python object that you would normally expect. Next, we can simply load raw data from a file, and all it's going to do is just read the whole file and return all the file data as a string. So if I run this, you see there's the raw output of our file written as a string, which should match our game.save file here. Next is load adders, and all this is doing is loading all the state of your values and attribute names back into your own custom object. So we just created a simple class with my data. We instantiated it, and then we pass in our object and then load the file name, which is our game.save file. And this is going to load all the names and values in that file into your custom object. And this does it in place, so there's nothing to return. So now if I run this, we should get that list of items from our game.save file. And there it is. Next is load dict. As you can imagine, this is just going to load our game.save file, but return everything as a dictionary instead of the maci object. So if we run this, see now all of our data stored in that file will be expressed as a dictionary instead, which can be useful. You can also load maci data from a string. So if your string is formatted with maci syntax inside, you can easily pass that string into the load string function, load your data. And now if I access .items, which should be our list here, and run it, you see our list comes back. Next is kind of the same concept of load dict from a file, but this time we're loading it from a string. It's just going to return the string of maci formatted data into a dictionary. So if we run this, now you see all of our maci formatted string data got loaded as a dictionary. Next is dumping your data. All I did was create a quick maci object using the maci.build, which creates an empty maci data object. Simply added the attribute names and values, and then select our file name, and then pass in your data. This should create a new game.save2 file that I named up here. That way we're not overwriting our other data. So if I run this, you see I printed our data as well. That's what it should have created, and we see our new file name here. I drag this over. There's our data stored to the file. You can also dump dictionaries to a file as well, and it'll be expressed in maci format. So I have my dictionary right here using the same names and values, our same file name, and then our data. And if I run this, see I printed our data and then it's showing in dictionary format. And if we go to our game.save2 file, there's our data. Additionally, you can also store your custom data objects to the file. It'll be structured in maci as well. So I have my instance attributes here using the same names and values. I instantiated creating my obj, stored my data here with the same file name. And if I run this, and drag the file over here, we'll see that, again, our usernames and values are stored to the file. And remember, you can load these names and values back into your object using load adders that we talked about earlier. Next, you can simply dump your data raw to a file. So if you have any raw data you just want to store to a file, just use dump raw. Then we have our file name and then our data. So if I run this, see it created the file, and then we have our raw string data that we just dumped to the file. All right, lastly for dump, you can dump your objects to a string as well. So all I did was just create the same basic maci object, accessing dump stir, and then passing our data in, and it returns a maci formatted string. So if I run this, you can see our maci data is formatted into a string, just like you would expect in the file. And you do this with a dictionary, and of course pass your custom class object, just like we demonstrated with the file, to get the same result. All right, next we'll show some of the features like locking. So if I were to lock an attribute name, this would be like creating a constant. All you do is do +L, and then this will lock the attribute from being modified in the runtime of the code. So if I run this, it's actually going to throw an exception. And it tells you attribute name locked cannot be reassigned attribute money. Now I'll try hard locking the attribute, which is just the letter H, and this does the same thing, except it also protects against deletion. So if you try to delete this attribute and run it, it says attribute name hard locked cannot be reassigned, deleted, or unlocked. And so that effectively gives you the ability of like having a constant. Next is mapping. If I were to do +M on this now and then specify the attribute name, this attribute name is going to follow whatever attribute name's value this contains. So no matter what changes here, this will always reference the same value as this attribute name. So right here, as you can see, we first print the original values that it was mapped to, we reassign money only, and then we'll also see reference money change as well. So if we run this, you see it first printed 1000, 1000, we changed money, and now they both show none. This effectively gives you the ability of almost having like a pointer-like feature. Next, I'll quickly go down the list of all the object methods that are available on the maci data object. First, we have unmap adder, which will unmap the mapping of an attribute name to another. We have unlock adder, which will unlock any locked attribute names. However, it will not work on hard locked attribute names. Those are permanently locked throughout the runtime of the program. We have map adder and lock adder, which does the same exact thing that you saw in the file, as well as hard lock adder. Then all the ones that say maps, I'm going to skip those. Watch the full training series to understand what those are doing. And then you can also get a quick list of your locked attribute names and hard locked attribute names as well. And get adders will take your maci data object and return a dictionary of your currently stored attribute names and values. All right, now we'll take a look at the external libraries you can easily access in maci. So we'll start with JSON, and we have our file name called game.json, and if you want to load a JSON file, you just do JSON load and then your file name. We store it to data and we run this, so you loaded all of our data into a dictionary. And just to quickly reference, here's some of the same data we were working with so far. Next, we can load JSON data from a JSON formatted string, and then just use the JSON load stir, or str, or however you want to say it. So we run this, and so we get a dictionary back of our JSON formatted string. Next, we could dump data to a JSON file just by using JSON dump. We have our file name and then our data. So if we run this, it should create game2.json, which it did. And as you can see, there's our data stored as JSON. And then lastly, we can dump our data to a JSON string just by using dump str. So we put in our data and it returns a string formatted in JSON. So if we run this, there's our data in a JSON formatted string. Next is YAML. We want to load our data from a YAML file. We just do YAML load and then our file name. Store it to the variable and run this. And as you see, our data is represented as a dictionary in this example. We'll move this over just to show what our data looks like. Next, we can load a YAML formatted string just by simply using YAML load stir and pass in our YAML formatted string, and we run this. It returns our data represented as a dictionary here. Next, we could dump our data to a YAML file. We just do YAML dump, our file name, and then our data. If we run this, it creates a new file called game2.yaml, and there's our data. And lastly, if we want to dump our data to a YAML formatted string, we just do YAML dump stir, and then our data. Pass that into a variable and run this, and you see there's our YAML data in a formatted string. All right, next is TOML. If you want to load your TOML data from a TOML file, you just type TOML load, your file name, we store it into a variable, we'll run this, and there's our TOML data. Next, if you want to load your TOML data from a TOML formatted string, you just type TOML load stir, and then your TOML string data, and then run this. And then there's our TOML data loaded from a TOML formatted string. Next, if you want to dump your data to a TOML file, you just type TOML dump, and then your file name, and then your data, and we'll run this. And then this created a new file called game2.toml, and there's our data. And lastly, if you want to dump your data to a TOML formatted string, you just type TOML dump stir, and then your data, and we'll print this out. And then there's our TOML formatted string. Next, we have ini or ini, however you want to say it. This tooling also loads CONF files or CFG files, so keep that in mind. So I have our game.ini file. So we have our section game_data and then our key value pairs. And so if I were to load this, if you run this, it just gives you a config parser object back. Please look up the Python official documentation to learn more about how to handle config parser objects. But simply, if we just type the section key name, game_data, and then let's just pick username and run this, we get our value. And all values stored in an ini file or CNF file are always going to be a string. So each one of these are always going to return as a string. Next, if you want to dump your data to an ini file or CNF file, Maci does come with an auto build tool, so you don't have to worry about managing a config parser object, as long as you follow the structure. The structure is simply every parent key name or first key name is always the section name, and then your sub key names is always the sub names and values under the section. You pass that in using any build auto function, it'll return your config parser object. And then you just pass in your file name and data to any dump function. So if I run this, this should create game2.conf. And if we open this, we can see our section name, which is the parent key name, and then the sub key names and values. Next is XML. If we want to load any XML file, we just type XML load dict, our file name, and then run this. And then there's our data returned as a dictionary. And if we open our XML file, you see all of our XML data to match the data here. Now quickly, I want to state there is alternatives to XML in the Maci library loading element tree objects instead, but I recommend using the dict functions associated with XML, as that makes it the easiest to handle and manage your data. Next is loading our data from an XML formatted string. All we do is just type XML load stir dict and then our string, and that should return a nice dictionary back for us, and it does. Next, if you want to dump your data to an XML file, first you just got to make sure that your data is structured accordingly. The first key is always the root element inside of your XML file, and then you can have as many sub-elements as you want, so just keep that in mind. You only need one. You can't have two, so if you have another top-level key, it's actually going to break. Then we just type XML dump dict, our file name, and then our data, and run this. It should create a new game2.xml file, and then there's our data. And then lastly, if you want to dump our data to an XML formatted string, we just do XML dump stir dict, pass in our data, and then run this. And as you can see, there's our XML formatted string printed to the terminal. Lastly, I'm just going to show you a couple of quick useful utility tools that Maci comes shipped with as well. The first one is clean format. So first we just get our data from our game.save file, and then I convert it to a dictionary using the getAttrs method. So I run this, and as you can see, our data has been converted to a dictionary, but you can imagine having a lot of data being very difficult to read. So if you were to run this through the clean format function, you can get a nice formatted clean string to easily view your data. So all I did was just run clean format against our dictionary data, and then now I'm going to print that clean view to the terminal, and now you can see all the data in that file got first converted to a dictionary and then now neatly printed out into the terminal. This makes it so much easier to distinguish, especially when you have a lot of nested data. Lastly, we got some cool hashing tools that makes it easier to get the hash of a file or a hash of your data, and even do some neat comparison. Let's say I wanted to check the simple integrity of a game.save file if it's been changed or not. What you would do is specify your source file, which is the game.save, and then specify a destination file where to store the hash. So you'll run create file hash, and then specify your source and then destination file. And this will capture the current hash state of the file. So if I run this, see, it created a new file called game.save.hash. If you open this, you just see it has simple hash data in there, and currently default it uses SHA-256. Now, let's say at some point in your program you want to see if the integrity of the file has changed. You can simply use compare file hash, which will again take the file name source and the source file of your file name hash that you generated, which has the captured current hash state of the game.save file. All this does is return a boolean to compare hashes to make sure they're the same. So if I run this, currently it's true. Nothing has changed. But if I go into my game.save file, and if I change even one character in here, so let's just remove like the letter D, for example, and run this now, it says false because the hash of the file has changed, which signals to you that the integrity of the file is not correct or corrupted or has been modified. Also, if you create a file hash, it always returns a string of the hash, which you can capture here. If you don't want to create a stored hash of the file, just pass in none on the destination, and that will just give you the hash only. So if I remove this file and just run this, you see we just get the hash of the file only and a new file does not get created. And lastly, if you simply just want to get the hash of your data, like a string, all you have to do is use create hash, pass in your data, and then we run this, and there's our hash of our string. All right, well, that's going to go ahead and wrap up this video. Again, if you want to go deeper in understanding macis and some of the parameters of the functions and methods, etc., please watch the full training series found in the description. Hopefully maci makes your projects just a little bit more efficient for you. I'd like to thank you for watching, and take care.